We will continue learning terms and definitions, moving on to lesson 7. Again, I ask your patience as I had substantial dental work today. So again, I may be slurring words, but at least I'm attempting to record this for you so that it will help you get through the class. The next terms that we're going to meet are those of standard deviation and variance. Now, I want to remind you that we just met 3 measures of central tendency. These were mean, median, and mode. Mean being the numerical average, median being the one in the middle when they're rank ordered, and mode being the most common. The term that is most used in statistics for measure of central tendency is that of mean. Now, we have a population and we have a sample. So we have a population mean and we have a sample mean. The population mean is represented by the Greek letter mu. And the sample mean is represented by the letter X bar. So if you see an X bar, that refers to the sample mean. If you see mu, that refers to the population mean. Now, when we met descriptive and inferential statistics, I told you that many times we take a sample, we describe the sample, and we use that to predict facts about the population. So you should be sensing that we will capture X bar, which is the sample mean, and we will use X bar to make a prediction about mu, the population mean. Actually, this will be called a confidence interval, which is another thing that we have yet to meet. You have 2 terms yet to know. You need to learn about standard deviation and you learn about variance. Standard deviation is the average distance of the data from the mean. That means we have a data set and we take the average and then we look at how far each of them is from the average, and we average their average distance from their distance from the mean, and that becomes the standard deviation. The variance is the square of the standard deviation. Now, you guys have been very blessed to live in the age of calculators and the age of computers. People my age remember when they met their first calculator. I used to be very good with a slide rule. That was a way of multiplying and dividing without having to have a battery. I was very good with it, but calculators did away with that. Now, back in those days, taking a square root was not as easy as just hitting a number on a calculator. So a lot of times people just, instead of taking a square root of something, they just dealt with the thing in its squared form. That's where variance comes from, a time when statistics was really done without calculators and without computers. If you take the variance and you take its square root, then you have the standard deviation, which is the average distance of the data from the mean. I thought it would be helpful to give you a little history of these terms. Allow me to explain. Standard deviation and variance are the same thing looked at from different perspectives. For example, 3 might be the standard deviation and 3 squared is 9, which would be the variance. That's very interesting because 3 squared and 9 are the same things, but they're looked at from a different perspective. 4 squared and 16, same thing. 4 would be the standard deviation, 16 would be the variance. 5 squared and 25, 5 would be the standard deviation, 25 would be the variance. Let us begin our journey. What is the standard deviation really, and how is it explained? Now let's take these 5 little ducks. You probably figured out I like pictures. So let's look at the population mean of these 5 ducks, considering their population. The population mean would be the average height. Some of them are taller, some of them are shorter. Standard deviation is the average distance from the mean. So if we looked at the distance and height from the mean for each of these 5 ducks, we added those 5 things together and divided by 5, then these distances from the average of them becomes the standard deviation. Let's average them. We put them together, we add them together, and the average distance is represented by the little bar there. The standard deviation is the average distance from the mean. We represent the standard deviation of the population with the letter sigma. You may guess that in mathematics they like using their symbols. Well, in statistics we like using ours. We like Greek letters. Mu is the mean of the population. Sigma is the standard deviation of the population. X bar is the mean of the sample. And S is the standard deviation of the sample. So you see, when you see sigma, you immediately know that you're dealing with a population, and that represents its standard deviation. If you see S, you're dealing with a sample, and that represents the standard deviation of the sample. The standard deviation, again, is the average distance of the data from the mean. The bigger the standard deviation is, the more the data are scattered. The smaller the standard deviation is, the more tightly packed they become. On to the formulas. Oh my gracious. Isn't that a scary formula? Sigma. So we know that we're dealing with a population. The standard deviation of the population is equal to each of the number. Kappa N is the number in the population. So we add up from 1 to n the difference of each of those data points from the mean. Kappa X represents the datum in the population, and we divide it by n minus 1. N minus 1 is done to help just pull it down a little bit and make sure that it doesn't overestimate the standard deviation. So sigma is equal to the sum from 1 to n of all the absolute values of the distance of the data from the mean, absolute value because distance is always positive, divided by n minus 1. And the standard deviation of the sample is represented by S equals the sum from 1 to lower n, which represents the number in the sample, divided of the distance of the sample from the mean, the sum of all the distances of the data from the mean, divided by n minus 1. These two terms you need to know: standard deviation, the average distance of the data from the mean, and we use sigma and S. And then if you hear the phrase variance, all the variance is the square of the standard deviation of the population, or the square of the standard deviation of the sample. I want you to know that you may panic over these terrible formulas and just have a mathematical conniption fit. No need to do that, because most of the time the standard deviation will be calculated for us. How many people walk around taking square roots by hand and doing all of their stuff without computers and without calculators? Not very many. And if they are, they're not very productive. In statistics, what we like to do is use statistical software or statistical packages that will help us do the things that we need to do. Now, actually, my friend, you can use SPSS and find the standard deviation and then calculate the variance, or you can use Excel to list a group of numbers, give it the mean, and give you the standard deviation. Excel will do it for you. You're not going to calculate it by hand. And I know there are stat teachers out there that believe you must calculate it by hand. What I believe is that you need to know what it is, and you need to know how to calculate it using software. If you use Excel or you use SPSS, then you're going to be very, very high level in my world. I do recommend, as we move through this course, that you transition to SPSS. I hate to tell you again that you can buy a student version of SPSS with very reasonably, an annual license for about $90. If you don't want to do that, just use Excel for a while to do your standard deviation and your variance. And when you do that, you will soon be able to transition to SPSS using a sample. You get a free month for a trial of SPSS. So that will let you finish up our course. Now you know all. Standard deviation is the average distance of the data from the mean. Sigma represents for the population. S represents for the sample. Variance is the square, sigma squared and S squared. Now you know all things. Keep climbing the ladder. You're getting your terms and your definitions. Look at what all you've learned. You've learned the difference between quantitative and qualitative statistics. You've learned descriptive and inferential statistics. You've met the terms such as the measures of central tendency, the mean, median, and modes. You know data is a plural term. Datum is singular. You know the different types of data. You're growing, and we will refresh you through all of these terms when we come to the end of Module 1. I want to thank you for your kind attention, and I'm very proud of you. You're making progress.